we're going to take a look at negative exponents, which are not evil, and they do exist. All right, so we have d to the negative third. Now, before we talk about this actual problem, let's talk about the rule. So we have a rule of in exponents, and there are a bunch of rules of exponents, but the one we're talking about today is a to the negative m is equal to 1 over a to the m. Now, if you can't read that, I'll rewrite it because it's unbelievably sloppy. So again, we have a to the negative m power is equal to 1 over a to the positive m power. So that's the rule that we're going to be working with. So in my first problem, I have d to the negative third. So d to the negative third is going to be equal to 1 over d to the positive third. And that's it. It's really that simple. So if I look at my second problem, this rule will also apply when you have a variable in the denominator with a negative exponent. We are going to end up moving it up. So this is just going to simply be equal to g to the second power over 1, which is obviously just g squared. Now, to get hyper technical, that would be the same thing as saying 1 over g squared. That starts getting confusing, right? If you really want an understanding of why this works out, if we look at this as a division bar, we have 1 divided by 1 over g squared. When you multiply with a fraction, you take the reciprocal and multiply. So that's why this works out. You don't have to remember all this. Don't worry about that too much. As long as you remember that the negative exponent is either going to move something up in the fraction, or in this case, it's going to move down in the fraction. Negative exponents don't make negative numbers, they make fractions. So if I take that to a slightly more complicated problem, we have p to the negative 2, f to the third, and we're taking the whole thing to the third power. Now, when you have a problem, a variable with an exponent taken to another power, you're going to multiply these exponents, which I'm sure you remember. So we end up with p to the negative sixth, because negative 2 times 3 is negative 6, f to the ninth. Now, we cannot express an answer with a negative exponent. That is just illegal. The po-po is going to come around and take you away. We're not having any of that here. So what is p to the negative sixth? Well, you'll remember that p to the negative sixth is just going to equal 1 over p to the sixth. So if I break this apart, I have 1 over p to the sixth times f to the ninth over 1. Let's multiply them together. Let's get them together. And we end up with f to the ninth over p to the sixth. And that's it. You're done. The same thing's going to apply when you have variables in the numerator and the denominator. It's not scary, I promise. All you got to do is break it apart. So let's say we have this p. Oh, that's a b. P to the third over 1. 40 minutes ago.
Are you serious?
Then I have this y squared, and that's in the numerator, so we have y squared over 1 times, well, x to the negative 2, well, just like this one, it moved up, right? So we're going to have x squared over 1. And then in the denominator, we have our 1 over y, because that y, nothing changes with it, right? So let's put this all together. So we have p to the third y squared x squared all over y. But wait a second. We have y's in the numerator, we have y's in the denominator. y squared divided by y is just y to the first. So they cancel out. So finally, your final answer is p to the third yx squared over nothing. I'll rewrite it so it's easier to see. P to the third y x squared. Perhaps we should flip it around because x comes before y, right, folks? So it'd look even better. P to the third x squared y. And the pen had no mistakes there. So that's how to deal with negative exponents. Really not too bad, not too scary. And these are really quick problems, which is nice. So happy simplifying.